everyone. Function f is defined over an interval a, b. So that's x squared plus 2 and from 0 to 4. We're going to approximate the area by partitioning 0, 4 into 4 subintervals and also into 8 subintervals. And in both cases, we're going to use u as our left endpoint. We're going to express the area as an integral. And for my class, we've already gone over this. We're going to also evaluate the integral with the evaluation theorem. So we'll get started. I went ahead and kind of drew the graph. This is just a bit of a rough sketch. So this is x squared plus 2 from 0 to 4. So if we're going to do the first one, and that's 4 subintervals. So that's basically 4 minus 0 divided by 4. So we're going by 1 unit. This equals 1 unit. And if we're using 0, what we're doing is we're going up to our point and then drawing over to 1, draw up, go over to 2, draw up, go over to 3, draw up, go over to 4. And then just kind of draw down like this. All right, and then for the 8, do the same thing, but you're doing it more frequently. So you just have a lot of these. Just keep going. And 3, 2.5 goes up to here somewhere. And 3.5 goes up to here somewhere. And then 4, 3 goes up to here to 4. And I messed up something in here, so this one goes up to here. Let me erase this. All right, so that's basically what that looks like. You're trying to get a graph of it. I'm fixing this a little bit. So I messed up. All right, so this one should go up as well. All right, so there's the intervals. And again, as stated in my other interval, we have these 5 endpoints. So we only need 4 endpoints. They want us to start with 0. So we're going from 0 to 3. 0 to 3 on both of these. Or 3.5 on this one. All right. So basically for the first one, we're going to approximate the area. We're going by 1. This one, we do 4 minus 0 divided by 8, which is 1/2. So our intervals are going by 1/2. And this is 0 here. So the way you do that, you're going to do for the first one, we're going to do area equals f of 0, and then you multiply it by the intervals you have. So that's going to be 1 plus f of 1 times 1 plus f of 2 times 1 plus f of 3 times 1. Now just multiplying by 1. So this one's going to be pretty easy. This is going to be 2 times 1 plus 3 times 1 plus 6 times 1 plus 11 times 1. So this is all going to equal 22 is the approximate area. Now I'm going to copy this page over and then erase this. So we're not going to lose anything I just wrote, but when I duplicate it, so I just duplicated it and I can erase this. So if you want to scroll back, this will be there. Now we're doing the 8 subintervals, so we're going to have to multiply everything by 1/2. So that's the only difference. We're still using approximately our area as we're starting at f of 0 times 1/2 plus f of 1/2 times 1/2 plus f of 1 times 1/2 plus f of 1.5, or let's just call this 3/2 times 1/2 plus f of 2, times 1/2 plus f of 5/2 times 1/2 plus f of 3 times 1/2 plus f of 7/2. That's your 3.5 times 1/2. Now, when you factor out the 1/2, it makes it easier. So all of these have 1/2 in them. So I'm going to factor out 1/2 and then just evaluate all the numbers. So you're going to get 2 plus 9/4 plus 3 plus 17/4 plus 6 plus 33/4 plus 11 plus 57/4. It's probably easy to put this one in the calculator. You can just add all those up and then divide by 2. And basically you're going to get, this is going to be 1, if you multiply through 1/2, 1 plus 9/8 plus 3/2 plus 17/8 plus 3 plus 33/8 plus 11/2 plus 57/2, and this is all going to equal 51 divided by 2, which equals 25.5. So if I compare this, we have 25.5, and the first one we did was 22. So usually the more that you do, the more exact you get. Now we're going to write this as a definite integral and evaluate. So the definite integral is going to look like this. We're going from 0 to 4. Write your function here. Then you write dx here. Now to evaluate the area under the curve, so that's exactly what we did with the trapezoid rule. We're going to integrate this. So this is going to be x cubed divided by 3 plus 2x. And then we're evaluating this from 0 to 4. We're using the evaluation theorem. And now this is our f, because this is our antiderivative of f. So all you do is you're going to use this. We're going to use f of 4 minus f of 0. So when you plug that in, you're going to get 4 cubed, which is 64. Let's just write it out the long way. So it's going to be 4 cubed divided by 3 plus 4 times 2 is 8. So this is 64 divided by 3 plus, if I want a 3 here, this is going to have to be 24 for that piece. Then we do f of 0. Well, when you plug in 0 on this, you're going to get 0. So this is all equal to 0. So this is going to be 88 divided by 3 minus 0. So that's your answer. And let's see how close we got. So 88 divided by 3 is going to be 29.33. It's repeating. This is repeating. All right. And that's it. Thank you. Have a nice day. Bye-bye.